Well, US space agency NASA says its Perseverance Mars rover has found potential signs of ancient life on the red planet. The agency has told journalists they found evidence of possible microbial activity in rock samples gathered last year from what's thought to be an ancient lake bed. NASA officials likened the rock formations to fossils and said it's the best evidence yet that living organisms may long ago have existed on our neighbouring planet. They stress, though, that more tests are needed, ideally back here on Earth, before concrete conclusions can be drawn. And it's great to be able to speak to one of the scientists behind this discovery. Mike Tice is a research scientist at Texas A&M University and is part of the Mars 2020 team. Congratulations to you on this really significant achievement. Could you just help us understand a little bit more what it is that you've discovered exactly?
Sure, thanks, Jared. So what we found, you saw pictures of them just now, are small structures that they're not quite what most people would think of as fossils. They're not bodies of organisms from long ago. They're a little bit more like, think looking through the garbage of potentially ancient microorganisms that were living out next to some lake on Mars. One of the ways that we think probably the best way to interpret these things is as the waste products, the chemical waste products of old microorganisms. And we see similar things in rocks on Earth where microorganisms were breathing different things and eating organic matter and sediments.
So some very exciting chemical waste products, I take it. Does it mean that some form of life could have been involved in forming these rock formations?
That's right. So the team that was examining this considered lots of different potential explanations for how these things could have formed, including things that don't involve life. Maybe one of the important things to know about this is some of the processes that we think were important in forming these without life typically take place at high temperatures. And using the best techniques that we could available to us on the rover, it doesn't look like these rocks ever experienced those kinds of temperatures. In contrast, on Earth, there are microorganisms that do those reactions regularly. And in fact, at the same time as these rocks were being deposited on Mars, there were organisms on Earth already doing this as well.
Okay, and how does this change, I guess, our and your understanding about Mars and the potential for more advanced life forms to possibly live there?
Right. These certainly weren't things that would have run by and waved at you as if we had a camera around at the time. Well, these organisms would have existed or more than about 3 billion years ago. Again, on Earth, there were similar organisms around. And on Earth, it took another several billion years before there were large, complex organisms, probably like the kind that you're thinking about here, animals. By the time that much time had passed on Mars, Mars really wasn't habitable at the surface anymore. And so we still think it's pretty unlikely that we're going to find that these things eventually evolved into something more complex like an animal.
Okay, fair enough. Now, is there ever going to be the chance to bring some of these samples back to Earth to look at them closely here?
I genuinely hope so. I think getting this sample back could answer some of the biggest questions that we have about life and its place in the universe. The best I can say is that it is technically feasible that we could get these samples back, and whether or not we do it is going to be up to governments to make the decision, and ultimately the people to decide if it's an important enough thing to do.
That was geobiologist and astrobiologist Mike Tice. Congratulations again, Mike, and thanks for your time.
Thank you, Jared.
So let's speculate wildly about this potential groundbreaking or perhaps a life-changing discovery with the editor of NASAWatch.com and former NASA scientist Keith Cowing. Welcome back to DW, Keith. A year-long analysis of data sent back to Earth from these rock samples which are still up there. What sort of life might scientists have discovered?
Well, finally, I get to talk to you about what I went to college for. I'm actually an astrobiologist by training. That's what NASA hired me to do. So you can imagine I'm a little excited by this, but a little careful about characterizing it. If you look what they found, and you can probably get an idea what they're looking at. If you go to somewhere where you work, look for an older building that's got travertine marble and you see these little lines in it. Those are remnants of life forms. And I've been to, if you look at some things though, like this rock, I'm holding it up, it's got lines in it. You might say, oh, it looks like leaves. No, but it's from an impact where it got blown apart by a meteor. So this doesn't show that there's life, but it shows that the conditions for life might have existed. And I've got one here of another one. So they look like things, but doesn't mean just because it looks like life, it is life. So what they did is they used the instruments on the rover, zoomed in on these little spots, and they called them leopard spots. And they found a chemical signature that if you look at it, there's a bump in the signature that's the same as if you look at those sort of fossils I mentioned on Earth. So lights went off. I think a lot of people thought that this was a good biosignature, which means it looks like it's something that life may have existed a long time ago, died, and left behind. There's no evidence yet that there's still life on Mars, but these rocks, 350 million years ago old on Mars, are the same age as rocks that look just like that on Earth, which have those sort of fossils. So we're kind of happy right now. We would like to bring the rocks back, but the money for that mission, well, that's sort of gone away.
Well, tell us about that, because why haven't they been able to bring the rocks back?
Well, the last time we brought rocks back from another world, we had two people walking on the moon, and they picked them up and they put it in, and we spent billions of dollars.
Oh, is that long
Right
ago?
now, to do it for Mars, you'd have to do it robotically. China has a mission, Tianwen-3, that's going to leave in 2028 and come back maybe around 2030 with rocks. We've been trying since, I remember working on this 40 years ago, to send a robot to Mars to pick the rocks up and bring them back. Our rover that's currently there has picked up samples and laid them out so that another spacecraft could come pick them up. But as they say, show me the money. NASA's had problems trying to come up with how they would do this, and the cost keeps going up. And the president's budget that just came out for just the next fiscal year cancels the mission. So it's in limbo. But yet the administrator today seemingly was thinking, yeah, if we're going to be excited about these rocks and we need to bring them back, we need to bring them back. So
Okay.
somewhere there's a decision that has to be made.
So where we're at is analysis of the data that this rover has sent back. So what more could you get from actually having the rocks in front of you here on Earth? And in fact, I'm gesturing as though I'm holding it, but would you actually hold them? Because who knows where they've been?
Yeah, you probably would. It would be inside a glove box, and you'd be inside a glove box because some people are worried that there's face-eating Martians from billion-year-old rocks. But that said, it would be akin to just looking at it more closely with a good microscope, but being able to actually chemically test and use the most advanced imagery we have on Earth that nobody has yet put in a rocket. And so that's the only way you could figure out for sure that based on everything we know about life as it's happened here, might have happened in a world that was like ours. And that's the point at which you got to go to Mars and look for more stuff, and maybe look in certain places that are like these old environments that may still exist. And maybe there's life there, but that's even more money, and that's, where it goes.
We'll have a whip round at work for you. Listen, we keep hearing there is this high probability that there is intelligent life out there. So why haven't we found it yet?
Well, if you and I were in a space station and we were looking down at Earth right now, Phil, would we think there's intelligent life here? I just have to say that. It's what does intelligent life look for elsewhere? Does it look like us? Are they octopuses? You just don't know what they would be. So the idea is, how do you look for it? But we're finding planets that, if we think life here is not totally unusual, we're finding planets out there that are a lot like our own that could host life. Doesn't mean they do, but they could. But there's also forms of life, like there's just a paper that just came out that where we were dumping our waste 40 years ago in the ocean that's poisonous and toxic. There's some bacteria that are having a great old time there. We didn't expect that. So what does life look like? What do they say? Are they waiting for us to talk to them? It's a very complex thing. That said, people are listening. Statistically speaking, there's so many planets. I'll get Carl Sagan, billions and billions. There's so many planets out there, and we've already found thousands that are close to us and hundreds that are like ours, that if there isn't life, we're missing something very important.
Listen, while I have you here, right, because I got in trouble when I was at school, by asking this question of my science teacher, because I used to watch Star Trek, and of course, they'd always talk about, well, it's life, Jim, but not as we know it. And my question was always, well, maybe we have seen a life, but just not recognised it. We just a rock that's just sitting there that could actually be alive.
Exactly.
And my science teacher told me I was being stupid.
Well, no, you were like, I got the same reaction when I built a sample return thing out of a wastebasket and a fishing line, and they thought I was goofy. I ended up working at NASA on the project, so there. But the thing is, you know, I was up at Devon Island, and I'm gonna just hold this up. Looks sort of like a fish without its fins. Well, that's what it is. I found a bunch of these lying in a riverbed, but I didn't see them at first because I didn't know what to look for. And then it's sort of called pattern recognition. And then I saw them. It's just like these shatter cones that I found. Once you suddenly know what you're looking for, suddenly you see it, but you got to know that you're looking for something that you may not expect to see. Science, that's what we call it. So, you know, again, two of us, you know, Star Trek fans at our own times, you know, there should be more of us in the world asking these questions right now. And there are.
All right, I hope my science teacher was watching. Good to talk to you as ever, Keith, editor of NASAWatch.com. Thank you.
Long and prosper.